The next section deals with equations for lines in space or planes in space. So we've learned how to calculate vectors and deal with vectors. So we've got two vectors, u and v. They're going to be parallel if and only if. So both if and only if there's a scalar k such that u equals kv. Now, if that k, the scalar it's a real number, if k is greater than 0, then they have the same direction. If k is less than 0, then those two vectors have opposite directions. And the final note on that is the 0 vector is parallel to all vectors because you can multiply a vector by u to get the 0 vector. So that'll work at all times. Okay. So the next theorem, 2.11, is parametric and symmetric equations of a line. So say we have some vector v with 3 coordinates, an a, b, and a c in this case. And it's passing through some points. This is notation for points. So the point is P, and it's got values of x naught, y naught, and z naught, whatever those 3 values are. So parametrically, the x value is going to be a combination of the x value on the points plus some scalar t multiplied by the a coordinate. Y will be a similar combination, only using the y and the y coordinate from the vector as well as the point, and the z will do the same thing. Again, the scalar that they're using a t here instead of a k, it's going to be the same for each of the parametric equations. And the symmetric equations are actually easy to find. Once you have these, if you note that these are just algebraic renditions. So if we look down here, this one, if we solve for t, we get x minus x naught over a. We solve for t for the second one, we get y minus y naught over b. And if we solve for t for the third one, we get z minus z naught over c. All right, so I pulled a homework problem number 244, and it's given instructions to do 4 things. We're going to do 3 of them in this video. So it says in the following exercise, points P and Q are given, and that's what's given in 244. And we're going to let L be the line passing through those points. So part A, we want to find the vector equation of line L. So, well, we're going to, I'm just going to use a V for this. V is going to equal our line P to Q. And finding that vector using these points, Q is going to, in this case, Q will be the terminal point. So we're going to take the x from Q, which is 2, minus the x from P, which is 4 for the first part, 3 minus 0, and 1 minus 5. And that's -2, 3, and -4. So this is our vector for the equation of line L. Now the parametric equation, so we're going to pick one of these points. I'm going to choose P here. And we're going to use P. We've got our x is going to equal well, our x naught is 4, so it's going to be 4 minus 2t because so it's -2 times t, or plus -2 times t if you want. Y is going to equal 0 minus, plus 3t. And z will equal 5 minus 4t. Now part C, we're going to take each of these and solve for t. So here we have 2t equals, this looks like 4 minus x. Well, let's go negative x plus 4. Let's do this. So negative 2t, we'll subtract 4 from each side, will be equal to x minus 4. We'll try to keep it in the same form that they've got it here. That means t is equal to x minus 4 over negative 2. Again, we're trying to keep it in the same sort of form that we have up here, where the x-coordinate is first in the numerator there. The other one we have here, that's just 3t equals y, which means that t equals y over 3. And our third one is 4t. There's negative 4t equals z minus 5, which means t equals z minus 5 over negative 4. So those will be our parametric, excuse me, our symmetric equations for those. And I'll start up another video, and the next one will deal with part D of this.